Hi, how are you all? So, myself Nagappa, you are watching Appa Chemistry classes. So, today's topic is states of matter. So, it is a class 11th, first physical chemistry chapter, that is states of matter, which is very important. So, from this chapter, we may expect the problems based on the kinetic energy, or sometimes they are asking the questions based on van der Waals equation. Sometimes they are asking the questions on gas laws. Mainly, especially they are focusing on the graphs. So those graphs I will explain in detailed manner with here total completion of this chapter for each and every video. I'm going to give you assignment for each and every concept of the whatever the concept which I am explaining on the based on that concept. So I'm going to explain the some problems and related some assignment questions also I will provide in the video itself only. You try to watch the complete video without any skipping. So then you will definitely will understand the concept of states of matter as well as the problems also. I think so you will not miss even a single question which is based on the similar concept which I am going to explain. Okay, so try to focus on this chapter. So I don't want to waste your time. So let's get into the video. So that is states of matter. First we are going to see the what is meant by matter and what are the different measurable parameters we have for the gases. Those all we are going to discuss. Now let's get into the video here. So first states of matter. In that, matter is nothing but the substance which has some mass and occupies some space is said to be what? A matter. Anything which has some mass and occupies some space, then it is said to be what? A matter. Now this matter are mainly classified into different categories. Now in our nature we don't go to in the deep, that is in lower classes which we had learned in 9th class level. So matter is classified into three categories at room temperature. At normal temperature, the matter is classified into three categories, that is solid, liquid and gases. Matter is converted to three categories. Those are solid state of matter, and liquid state of matter, and the gaseous state of matter. Solid state and liquid state and gaseous state of matter. Here we know that properties of liquid, gases, solids, what happens. In case of solids, the constituent particles are very closely packed or tightly packed. In case of liquid, somewhat far from one another. So somewhat far, but gases, they are separated by very large distance. So for that reason, gases are more compressible. Liquids are somewhat slightly compressible. Solids cannot be compressed. Okay, that is the main properties we have seen in lower classes also. Now the solid state and liquid state we are going to learn in the second year, that is solid state chemistry and solutions. So there we will discuss a complete study about solids and liquid. In this first year, class 11, we are going to see the gaseous state only. Other than room temperature, we have other states of matter also, plasma state, Bose-Einstein condensation state. So like the different states of matter will be there. So it depends on the what state of matter, mainly depends on the conditions, what temperature, what pressure we are maintaining. At normal temperature and pressure, matter will exist in these three states. Okay. So now in this case, now in this chapter, we are going to discuss only gaseous state of matter. Now the gaseous state of matter, in this case, now if you had seen the atmosphere mainly consists of, that air consists of around 78% will be nitrogen and remaining 21% will be oxygen. So very remaining that 1% of will be other component will be there, like argon, okay, and other gases, carbon dioxide, those gases are present. Most of the percentage of air occupied by this nitrogen and oxygen. Now in total periodic table, if you had taken, in total periodic table, how many number of gaseous elements are there, you know? So that is 11 number of gaseous elements are there. Out of 118 elements, how many gaseous elements are there? Gaseous elements will be only 11. So how many gaseous element? 11. What are those? Just you take the hydrogen, helium, neon, argon, krypton, xenon, radon. All these inert gases are comes under gaseous element. After that you can take the nitrogen, oxygen, fluorine, chlorine. So inert gases are 6 plus these are the 5 gaseous element. The total how many elements are there? Gaseous element, total of 11 gaseous element. In total periodic table we have only 11 gaseous elements only. So it is somewhat important one. In MSET they directly asked that how many number of gaseous elements are present in periodic table, that is 11. Is that clear? So that is what about a brief introduction about gaseous. Now we are going to see the what are the measurable parameters we have for the gases. So we'll see the measurable parameters. Measurable parameters of the gases. Measurable parameters of gas. Parameters of gases. So what are the measurable parameters of gases? We have mainly 4 types are they: pressure, volume, temperature and number of moles. These are the 4 measurable parameters for the gases. What is meant by measurable parameters here? Measurable parameters are nothing but the physical quantities which are used to calculate the gases properties, to give the properties of gases. Those physical quantities are said to be what? Parameters. Okay, so pressure, volume and temperature. First one we are going to see pressure. So here pressure is there, no, pressure is represented with P. So it is, pressure is nothing but what? Force per unit area. Pressure is nothing but force per unit area. Say for example, if any gas molecule is present in this container, so now the gas molecule will move in all direction. This gas molecule, they will move in all direction. When they are moving in all direction, they will hit with one another and as well as they will make the collision with the walls of the container. When they are making collisions with the walls of the container, so some forcefully they are acting on it. So that is force per unit area it is. So pressure is nothing but what? Force per unit area. If you had taken the units of units here, units will be, so pascals. Pascal is the SI system of unit and also Newton per meter square. Newton per meter square also unit of pressure. Okay, now pascals are Newton per meter square. Now and also the pressure of the gas molecule is calculated by using cistern barometer. Okay, now by using barometer. So by using barometer we can measure the pressure. By using barometer we can measure the pressure. So it is a barometer consists of what? One mercury column will be there. So that mercury column is placed in the, so whenever it is placed in near the sea level, so then what happens, which has the some reading on this mercury column. Now the reading will be from 0 to 100 centimeter it is. 0 to 100 centimeter, that is nothing but 1 meter. 0 to 1 meter, this all will be centimeter. When this barometer, cistern barometer is placed at near the sea level, if we are getting the water, one here 76 centimeter height of the mercury column indicates the normal atmospheric pressure. What is the normal atmospheric pressure? So when the cistern barometer is placed near the sea level, then what happens if that mercury has the 76 centimeter of height, then it is said to be 1 centimeter. 76 centimeter of which height it is? Mercury column. So 76 centimeter of mercury is nothing but what? 1 atmosphere pressure. We know that 100 centimeter is equal to 1 meter. So from this 1 centimeter is equal to how many meters? 10 power minus 2 meters. Okay. So now you see in this case 76 centimeter of mercury or 1 atmosphere pressure. It is also written as 1 atmosphere pressure is nothing but 1 atmosphere pressure is nothing but 1 atmosphere is equal to 760 mm of mercury. So here 1 centimeter is equal to 10 millimeters. 1 centimeter is equal to 10 millimeter. So we'll get the 760 mm of mercury or else 76 centimeter of mercury. Okay, na 76 centimeter of mercury come. Now that is 1 atmosphere is equal to this value. So this is the unit in case of millimeter and in centimeters. Just now we had seen in terms of pascals. 1 atmosphere is equal to 1.01325 into 10 power 5 pascals. 10 power 5 pascals or else Newton per meter square. Newton meter square. Newton per meter square. Now that is what pascals. In terms of pascals. Now here 1 atmosphere is also taken as 0.986 bar or else it is nearly equal to excuse me, 1 atmosphere is nothing but 0.986 bar, that is 1 bar atmosphere. So 1 atmosphere is also taken as 760 torrs. So these are the different measurements which we are using for the measuring of the pressure of a gas. Is that clear? These all values are very important. So in the calculation part. Now next we are going to see the next property, that is we'll see the first temperature, after that number of moles, last we'll see the volume. So why I am taking that last volume? So if you know the number of moles, then you can understand easily the volume term. Now first we are going to see the temperature. So temperature is nothing but what? It is a measurement of degree of hotness or coldness. It's called what? Temperature. Okay. So now this temperature is measured in two types. Generally temperature is measured in degrees Celsius if it is heavier one. But whereas gases will have the what? Very low temperature. So they are having the negative temperature. To avoid that negative terms, always the gases temperature should be taken in degree Kelvin. While doing the problematic problems also, most of the cases gases temperatures are taken in degree Kelvin only. How you are going to convert the degree Kelvin? So the temperature which is measured in degree Kelvins is said to be absolute temperature. What is meant by absolute temperature here? The temperature which is measured in degree Kelvin. It is said to be what? Absolute temperature. Now how you are going to get the absolute temperature here? T degree Kelvin, it is equal to degree Celsius plus 273.15. So if you are doing, then you will get the what? Degree Kelvin. So whatever the degree Celsius which we have, that value is added with 273.15 value. Generally we will take it as what? Only 273. When it is added, we will get the what? Degree Kelvin. That is the conversion of degree Celsius to degree Kelvin. Or else you can take it as degree Celsius is equal to, if you want to get the degree Celsius should be represented with small t and degree Kelvin should be represented with capital T. Now in this case what happens? T degree Kelvin minus 273. If you do degree Kelvin, from degree Kelvin, if you remove the 273 term, you will get the degree Celsius. So you have the what? Degree Fahrenheit also. How you are going to convert into degree Fahrenheit into degree Celsius, we will see. We will take the F minus 32 by 180 is equal to C minus 0 degree Celsius by 100. Now this formula, in sometimes they will represent like this also. That is F minus 32 into 5. That is 0 get cancelled. So 2 9s, 2 5s. That is 5 in the denominator, it will come into the numerator, by 9 is equal to C degree Celsius. So it is in degree Celsius. It is centigrade. Is that clear? So by using this formula, we can convert the degree Fahrenheit into degree Celsius. What is this 32 degree Fahrenheit? It is the lowest temperature in Fahrenheit scale. What is 0 degree Celsius? It is a lowest value in degree Celsius. So that F minus 32, C minus 0 degrees. Maximum temperature in degree Fahrenheit will be 180. The maximum temperature in degree Celsius will be what? 100 degrees Celsius. In a scale we are taking. So that is F minus 32 by 180 is equal to C minus 0 degree Celsius by 100. If you do that formula by using that, you can convert the degree Fahrenheit into degree Celsius. That is about temperature. I think so you got some information about temperature and pressure. Next we are going to see the number of moles. Here the number of moles of a gas can be calculated. Here number of moles. Now why we have to use number of moles? What is the role of this number of moles in gases? The gase's mass will be measured in terms of number of moles, which cannot be measured in kgs and grams, because the gases are very small and very weightless particles. Okay now, so if you are taking one gas molecule, so it has the water very less weight. So for that reason we have to take it as in terms of number of moles. How you are going to get this number of moles? It is, you are going to get weight of a gas or given weight of a gas, given weight of a gas by gram molecular weight of a gas, that gives you number of moles of the gas. Now how you are going to get this number of moles? What is the relation between gram molecular weight? You all know. So that is number of moles can be calculated by given weight of a gas by gram molecular weight of a gas. Now say for example, the whatever the weight which is contains one molecule of a gas, one gram molecular, 1 mole of a gas is nothing but water. 1 mole of weight of gas is 1 mole of weight of gas. 1 mole of weight of gas is always equal to gram molecular weight. Is it or not? It is what 1 mole. Then its weight will be what happens? It is 1 mole means it is equal to what? Gram molecular weight. 1 mole of weight of any gas is equal to gram molecular weight of that gas. Gram molecular weight of gas. So that is, you take the, for example, if I am taking 1 mole of hydrogen gas, 1 mole of hydrogen gas, weight is how much it is? 2 grams. So similarly 1 mole of oxygen gas if I am taking, 1 mole of oxygen, that is 32 grams. If I am saying oxygen atom, then it is 1, that is what 16 grams it is. Now I am taking the what? Oxygen molecule, so mole, 1 gram atom of oxygen weight is 16 grams. So similarly 1 mole of nitrogen weight is, 1 mole of nitrogen is 28. So similarly 1 mole of carbon dioxide, 1 mole of carbon dioxide will be 44 grams. Now what is mean by mole here? Mole you will understand in a better way in stoichiometry. Here I will say simply, so mole is nothing but it is a group of particles. Say for example, so what is mean by dozen? Dozen indicates 12 articles. Okay now, so either it may be 12 eggs or it may be 12 bananas or 12 mangoes, whatever it may be. So the dozen, the word which indicates the what, it is a group of particles. Here also mole indicates, mole is the term which is used for the group of how many particles you know? 1 mole indicates 6.023 into 10 power 23 particles. Those particles may be, it may be atoms or it may be molecules or it may be ions or it may be electrons or it may be protons or neutrons, whatever it may be. So that is what 1 mole indicates, these many particles. Now here 1 mole of hydrogen gas is nothing but 2 grams. That is nothing but how many molecules of hydrogen gas weight is 2 grams? Avogadro number. This is also called Avogadro number of molecule. It is also called Avogadro number of molecule. What is the birthday of Avogadro? Here birthday, Avogadro's number. How to remember here? Easy. This is 23. Here numerator also. The power of 10 will also 23. Now here 10th is what? October. So October 23. 23rd October is the 23rd October is called what? Avogadro's birthday. Simple for remembering. So the birth date of Avogadro's will be what? 23rd October. Then its value is what? 6.023 into 10 power 23. Just for remembering, 23rd October. October is the 10th month. 23rd is the date. Is that clear? So there is a simple trick to remember that one. So is that clear? Now here 1 mole of hydrogen is nothing but Avogadro number of molecule weight is 2 grams. That is, beside the 6, after the 6, how many zeros we have to keep? 23 zeros we have to keep. It is a very, very highest, biggest value. So highest value, that highest value of molecule, those many number of molecule weight is 2 grams. If you are taking only one hydrogen molecule weight will be, what happens? It is 1 by 6.023 into 10 power 23 grams. It is very, very, 2 by 6.023 into 10 power 23 particles, 23 hydrogen molecule. That is very, very less value you will get. That is 10 power minus 23, in terms of 10 power minus 23 you will get. That much small gram weight, it is one hydrogen weight is very, 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 very less. So for that reason, always the mass of the gases should be taken in number of moles. I think so you have got some information about number of moles. Why we are using number of moles for the gases instead of using grams and kgs for each molecule. So we are not calculating the weight of a gas for each individual molecule. We are taking in terms of number of moles or in terms of number of gram atoms. In that manner we are calculating. Is that clear? So next we are going to see the volume term. Last term, but it is very important. Next one is volume term. So volume. So it is very important one. So volume occupied by the gas molecule is nothing but what? Volume of gas is nothing but it is equal to container volume. Okay, how much? Say for example, what is the volume of the gas which is present in this room means it is equal to the volume of the room. Okay, that is what we are calling volume of the gas. In generally, what happens? Every 1 mole of any gas, occupies how much volume? 22.4 liter. 22.4 liter at STP condition. 1 mole of any gas occupies how much volume? 22.4 liter at STP condition. That is standard temperature and pressure. That is standard temperature is taken as 0 degree Celsius or else 273 degree Kelvin and 1 atmosphere pressure is taken as standard condition. At that standard condition, at constant temperature and pressure, 1 mole of any gas will occupy how much volume? 22.4 liter. The volume occupied by 1 mole of any gas is said to be gram molar volume. Which is very, very important. What is mean by gram molar volume here? The volume occupied by 1 mole of any gas at STP condition is said to be gram molar volume. This is very important one. I think so you have understood what is mean by gram molar volume. If I am taking the 1 mole of hydrogen gas, 1 mole of hydrogen gas volume is how much? 22.4 liter. If I am taking 1 mole of oxygen gas, it is also 22.4 liter. So if I am taking 1 mole of carbon dioxide gas, it is also 22.4 liter. So here, irrespective of the nature of the gas, at STP condition, all the gases will occupy how much volume? 22.4 liter at STP condition. That is very, very important. So here, whatever the gas you take, irrespective of the nature of the gas, the gases, 1 mole of any gas will occupy how much volume? 22.4 liter at STP condition. That volume occupied by the gas at STP condition is said to be gram molar volume. Is that clear? So which is very important one. And what are the different units we will use for the calculation of volume we are going to see now. Now next one here, volume. What are the different units we are going to use? Here we will see. So volume is taken in what? 1 liter in terms of liters. So 1 liter is nothing but 1000 ml. We know that 1 ml is equal to how many centimeter cube? 1 ml is equal to 1 cc. It is nothing but centimeter cube. 1 centimeter cube. Cc is nothing but what? A centimeter cube. So in place of ml, you can substitute that centimeter cube. That is 10 power 3 centimeter cube. So we know that 1 meter is equal to 100 centimeter. So from this 1 centimeter is equal to 10 power minus 2 meters. Now you substitute in place of centimeter, you substitute that 10 power minus 2. 10 power minus 2 meter whole cube. Then what happens? It is 10 power 3 into 10 power minus 6 meter cube. So bases are same, power should be added. That is 10 power minus 3 meter cube it is. So that is 1 liter is equal to 10 power minus 3 meter cube. 1 liter is equal to 10 power 3 centimeter cube. 1 liter is equal to 1000 ml. This 1 liter value, this 1 liter is equal to 10 power minus 3 can be written as 1 by 10 meter whole power cube. Can I write like this? So 1 by 10 is called deci, 10 is called deca, 5 is called penta, 1 by 10 is called deci, 10 is called deca, 1 by 10 is called deci, 1 by 5 is called 5 is called penta, 1 by 5 is called penti. Okay, so that is what 1 by 10 is called what? Deci. Here meter cube, decimeter cube. So that is 1 liter is equal to how many decimeter cube? 1 decimeter cube, which is very important. These are the different units which we will use for the conversion of volume terms. Is that clear? Now we have total of how many parameters? 4 parameters we had learned in detail. So what are the different units we are using for pressure, volume, temperature and number of moles of gas? Mass of a gas is taken in terms of number of moles. Now based on these 4 parameters, we are going to have main 4 gas laws. Those gas laws we will see in the next video. So till now, those who not subscribed, please do subscribe for continuous videos of this states of matter, including assignments. So similar model question I am going to give you in the video itself only. Okay na? So don't forget to watch complete videos. Thank you. Have a nice day. Keep watching Upper Chemistry classes.